Hi everybody, welcome back. I'm Miss Sarah. I'm one of the geometry teachers, and today we are going to be talking about the shape of distributions of data. So far we've been able to create these data sets, right? We've been creating dot plots, histograms, stem plots, and so by the end of the class today, you're going to be able to use some new vocab words to identify the shape that the data set takes on. So when we describe the shape, right, of a dot plot, histogram, or stem plot, for example, some vocab words that are going to come up today are one, symmetric. Data set can either be skewed left or skewed right. Data can take on the shape of a uniform, or it can have a normal shape. And data sets can also have these other features called gaps or outliers, and we're going to learn what those are and how to comment on those as well. So just a few things we're going to be seeing in this video today. All right, start us off, the word symmetry. We've definitely all heard this before. When you think symmetry, what do you think of? Maybe pause the video and reflect here. You might have heard this word when you're taking Algebra 2, when you're identifying an axis of symmetry, for example, or more basic if you think of like the features on your face, and if you split it down the middle, for example, does your left eye match up with your right eye? Or if you fold a piece of paper in half, does it look the same on the left as it does on the right? Okay, so a data set can be symmetrical. So if I draw a line straight down the middle here, or if I folded this piece of paper in half, the data set on the left would look the same exact way as it does on the right. And here's another example with just more data points. These two are both histograms, you can see, and they are both symmetric. So pretty basic. I'm going to try to draw here. Everything on the left. Here we go with my pen. Okay. Now we're talking about peaks. Peaks on a graph. So it's a point on the graph that is higher than the points directly to the left and right of it. And so we always want to pay attention to peaks in our data set because it's where the data is clustering, right? The higher the peak, for example, on a histogram means the more numbers that fall into that bin, right? It's kind of where the data clusters or the modes of the data set, which we're going to learn. So here we have a peak, right? This histogram has one peak. And so this is a good start for your notes here. Having one peak, we use the vocab word unimodal. It has one mode, it has one peak. All the data set, or the highest amount of data points are this number 5. It has one peak. Histograms or data sets can have more than one peak. For example, in this data set, right, most of the numbers fall at 2 and 6. And so this histogram has 2 peaks. And when a graph, a histogram, a dot plot, for example, has 2 peaks, we call it bimodal, 2 modes. So one peak is unimodal, 2 peaks is bimodal. If you're really curious, a data set can take on more than 2 peaks, and that would be called multimodal, a multimodal data display. Okay, so one of the features that we're looking at here is where the data numbers cluster, where there's a peaks. When there's one peak in the data set, it's unimodal. 2, we talk about a set being bimodal. So the most common shape a graph can take on is called a normal distribution or a normal model. So what this is it's a bell curve, and you probably heard this before. It does have one peak here at the top, and it's symmetrical. So all words we've heard before, right? This dot plot, for example, if I just trace it, again, we're not talking like the exact, like this histogram. I'm not going to like trace my pen like this, like stepping stones here. We're talking shape, which means the rough shape of this. And if I trace the rough shape here, it's symmetric, it's unimodal, and it's normal. So it takes on that normal model, the normal distribution, or the bell curve, right? So both this histogram and this dot plot have a bell curve. And that's how we would identify those. Data can also be, and data distribution can also be skewed. So we talked about being symmetric, having one mode, and being normal. It can also be skewed, and it depends which way it's skewed. It can be skewed left or skewed right. So a graph is skewed left if it's highest at the right and then becomes lower, and this all probably does not make sense to you unless you see a picture. But here's some pictures. So skewed left, I'll go with first. So skewed left, it's highest at the right, right? So all the data kind of clumps over here on the right, and then it becomes lower as it goes left, or it tails left. And if I draw an arrow, it depends on what way you draw the arrow, right? So the data starts up high on the right, and then I draw the arrow down to the left. That means it's skewed left. So it's kind of like whichever way the arrow is going. It's going in the negative direction or tailing left. That means it's skewed left. And so same goes with being skewed right here. It's graph that's skewed right if it's highest on the left. So here our highest point of data is on the left, and then it is being skewed right or tailing right as I draw my arrow kind of descending to the right. This graph would be skewed right. Okay, skewed left, tails left. Again, I draw my arrow to help me. It's tailing left, it's skewed left. If a graph tails right, it's skewed right. So here's an example. Say we take a math test, right, in our class, and then I make a histogram out of our scores. Would I, as the teacher, wanting everyone to do well, obviously, want our scores to be skewed left or skewed right, and why? So pause here. I will put up some examples, like these same pictures I had on the last slide. We're talking math scores here, right? I want everyone to do well. I want everyone to get a high score. What would I want my histogram to look like? Would I want it to be skewed left or skewed right? You can pause here and kind of think about this while I get my pen out. So this graph has the scores and the majority of the data clustered on the right, which means they're clustered on the high scores, which means the majority of my class did well here. And then I have a few who did poorly, right? So it's lower on the lower scores. This is being skewed left. We'll compare it as I try to write left with my pen here. Here, the majority got a low score, and then I only have a few students who did well. This is being skewed right. So if we were to take a math test and I'm recording some scores, I would want the data to be skewed left, where the majority of people did high and they're clustered in the right side of the data, and then a few people didn't do so hot, maybe they didn't study, they're over here in the left side, it's being skewed left. A uniform set. So in a uniform data set, the heights of the bins are, or like the data points, for example, this is a dot plot, not a histogram, but the heights are roughly the same. And I say roughly because they don't have to actually be the same height. Like, for example, all these dots don't need to fall at 5 all the way across, or all the bars in this histogram don't need, here they are all the same height, but roughly, right? So this dot plot is uniform as well as this histogram is uniform. And if you think about, like, this just looks like a big rectangle to you, but we know that there are bins here, right? I'm writing with a red pen on this red block, but here are the different bars, and they're just all the same height, so that's why it looks like a rectangle. But when they are all the same height, we know that that data set is uniform, or roughly. They can be exact or about, like as a dot plot, okay? A uniform shape is when the heights of the bins or the dots are roughly the same. Oh, it's pretty straightforward. Uniform. Here we go. We're on to some unusual features that graphs can have. So data distributions can have gaps and outliers, and we're going to talk about both and what to do and what those look like. So gaps are an area where there's just no entries in the data. So there's just like a blank space. That's a gap. So here's an example. In this histogram, there's no data that falls between what? Here to here. And so we always want to kind of picture that in the context of the problem. This doesn't have a title or axes labeled. We just know that there is a gap. But when it's tied with units or a title or a context, for example, we always want to think like, what's going on there? What is happening? Why is there a gap there? The other feature a graph can take are outliers. And so an outlier is an element of the data set that's either much higher or much lower than the rest. And here's what one would look like. Here's my histogram. It's going pretty symmetrical here, right from 0 to 5. Pretty normal distribution, but there is my outlier right there. If we're talking about, I don't know, the number of candies you ate, and everyone's eating between 0 and 5, and then we got someone over here who bought like the jumbo size of candies and is eating 9, there's my outlier, right? It's much higher than all the other elements. Outliers can either be bigger or smaller than the rest. So like I said, when we have these special features like gaps and outliers, we want to analyze them, right? We want to ask ourselves, well, what's going on and what is causing this? So here's an example of a histogram that's talking about sugars and cereals. And so on the side here, on the y-axis, we have the number of cereals, and then on the x, we have the sugar percentage. And so if we look at this, right, we have the majority of our data clustered around the 0 to 24, right? We have some high bars going on here. 0 to 24% of sugar is where the majority of the data falls. Then it gets lower, but in here we have a gap, and in here we have a gap. So kind of picture like the cereal aisle in the store, for example. Why are there no cereals from in this range here? Or why are there no cereals, sugar percentage of cereals in this range here? There's two gaps in this data. Okay, so we kind of want to identify why, and then when we say there's a gap, we have to say from what to what, for example. Here we're talking about a dot plot that has an outlier. So our data ranges from 6.5 to 9, but over here, I'm probably covering it. I can move myself out of the way. There's an outlier at 13. And the context of the problem tells me we're talking about shoe sizes. So we have the majority of people having shoe sizes between 6.5 and 9. And then there is a person with a shoe size of 13. So we would ask ourselves, like, I don't know, what's that person's height maybe? What ages are we talking about? Why does someone have a shoe size of 13? If we're talking about middle schoolers, for example, I don't know. But like what's going on with the gaps and outliers are super important to identify. Once we identify them, we kind of put it in context of the problem. So to recap this video, we need to be able to identify, first we make the graph, right? Then we look at the shape and we need to identify if the data set is symmetric or is it skewed? If it's skewed, is it skewed left? Is it tailing left? Or is it skewed right? Is it tailing right? We can also look at a data set and decide if it's uniform, if all those bins and dots are the same height, or how many peaks does it have? Does it have one peak, being unimodal, or does it have two peaks, being bimodal, or does it have 3, 4, or 5 peaks, being multimodal? Then we can also look at the data distribution and identify any gaps and why those are occurring, and also identifying possible outliers, remember high outliers or low outliers. We're going to see all these vocab words come to life in our examples throughout the week, and hopefully you took some good notes and this was helpful. See ya!